Hey, good afternoon, everyone. This recording is for Tuesday, January 12th lesson, and there's a couple things we're going to go through. We'll talk about a bell ringer, then we will watch the Science of Glow Sticks video. You will make a post, and then we will go through a quick virtual lab to demonstrate thermal energy. Please remember that you do have a quiz in class on Thursday, January 14th. So let's take a look at the bell ringer now. So here's your bell ringer. It says, explain what type of bond is occurring in the figure below. Earlier in our lesson this week, we learned about the difference between ionic and covalent bonds. In an ionic bond, electrons are officially being transferred or moved or given away, resulting in a formal charge. In an ionic bond, electrons are being shared. So notice in this example here, we have a carbon and 1, 2, 3, 4 hydrogens. And you can see that these atoms are actually overlapping in close contact and that these electrons are equally shared between all 5 atoms. So this is an example of a covalent bond. Another way to recognize this as a covalent bond is that it occurs between 2 nonmetals. So a nonmetal to a nonmetal will interact in a covalent bond, and a metal to a nonmetal will interact in an ionic bond. So this is in fact an example of a covalent bond. This is methane, CH4, and again, notice equally shared electrons. So now we've gone over that bell ringer. Let's go into the Science of Glow Sticks, and I'm going to get ready to share that video with you in just a moment. After the video is over with, you should click on the discussion post in whatever class you're in, and then you're going to respond. It says, in your own words, explain how a glow stick works. What can you do to prolong the life of a glow stick? So these are the 2 things I want you to listen up for when we watch the video.
Hey, it's me, Lauren. You've seen glow sticks before. They bring a festive glow to Halloween trick-or-treating. Hey, it's me, Lauren. You've seen glow sticks before. They bring a festive glow to Halloween trick-or-treating and New Year's Eve celebrations, and they're useful gear for explorers from scuba divers to spelunkers. When you find a bunch of people gathered to party in the dark, at least a few of them will probably be wielding glow sticks. But what the heck are these things? How do they work? Glow sticks are powered by a process called chemiluminescence. Don't let the name scare you. Luminescence is just a fancy word for any emission of light not caused by heating. The chemiluminescence in glow sticks is a pretty simple reaction caused by mixing chemical compounds. Compounds are made up of different elements bonded together in specific proportions so that they can't be mechanically separated. It takes a chemical reaction to sort out, for example, the oxygen from the hydrogen in water. When you mix a compound with other stuff, you can set off that reaction. And as the atoms rearrange themselves, they'll either absorb or release energy. If you look inside a glow stick, you'll see that there's a small glass vial in the tube. This vial typically contains a hydrogen peroxide solution called the activator. It's floating in a solution containing a compound called phenyl oxalate ester and a fluorescent dye. When you snap a glow stick, the vial breaks, and the hydrogen peroxide reacts with the phenyl oxalate ester, creating 2 other compounds, phenol and peroxy acid ester. Still with me? Good. The peroxy acid stuff is unstable, so it decomposes and produces additional phenol. It also produces a cyclic peroxy compound, which decomposes to carbon dioxide. This decomposition releases energy to the dye. The electrons in the dye's atoms jump to a higher level, then fall back down, releasing energy in the form of light. The other chemicals in the fluorescent dye determine the color of this light. Now, all of this happens within moments of snapping and shaking your glow stick. Depending on which compounds are used, the chemical chemical reaction can continue for anywhere from just a few minutes to a few hours. Warmer temperatures will accelerate this reaction, making the stick glow brighter, but for a shorter period of time. When it's cooler, the reaction will slow down, making the light dimmer, which means that if you want to preserve your glow stick, put it in the freezer overnight. It won't stop the process, but it will slow it down and drag out the reaction. So it turns out that there's some pretty nifty science behind the humble glow stick. Check it out the next time you're scuba diving, partying, or, you know, whatever it is that you do in the dark. Thanks for watching. Is there any other party science that's always mystified you?
All right, so hopefully you guys found that video interesting. So now what I'm going to do is I'm going to exit out of this video here, and we're going to go back into Schoology. And so now you guys should address these questions. So in the video, they discussed how a glow stick is two separate chemicals separated by a glass tube. And when you snap it or break it, the two mix. And let me change my sharing screen really quickly. The two mix and combine, and it results in a chemical reaction. And we can view that or see that as a bright or glowing color. They also mentioned that you can prolong the life of a glow stick by sticking it in the freezer. That's because it slows down the rate of the reaction. And that kind of leads us into where we're going for the rest of the week is we are going to look at the rates of reactions. So let's take a look at the next assignment. This is called Lab 1, Thermal Energy and Matter. There is a PDF attachment, and there's also a link. For this activity, you guys can do it on your own paper, or you can do a create a submission and respond. You can see that other students have done that. But basically, you're going to read through the attachment, and then you're going to open up the link and work through and address these particular questions here. So when you download the attachment, it says Lab 1 Thermal Energy. You can click on that, and it's going to open up as a PDF. So everyone is instructed to read through the assignment. It is going to give you some background information. It's about a 5-minute read. After you've read the assignment, you're going to go through the Your Task portion. Now, this is a modification of a lab that we typically did in class using water in a beaker. But what I want you to focus on using the virtual lab we have today is what happens at the molecular level when thermal energy is added to a substance. So what can you observe when you add energy to the system? And we're going to use this whole idea of a system to represent what will happen during chemical reactions. So once you've read through the lab assignment and you have your background knowledge, go back into Schoology and open the link. At the bottom, you will see energy forms and changes. When you click on that link, it's going to open up the PhET lab. There are two examples. So there are system and the intro. We're going to focus on the intro for today's activity. So when you click on that, there's going to be a few things you see. You're going to see water, olive oil, brick, iron, thermometers, and some heating apparatuses or burners. One of the first questions in the lab right here is what materials were required for this lab? Well, this is a pretty simple question, but you guys are setting this up as if we were doing the lab in class. So you should make a note of all the materials that were required. So everything you see displayed in this virtual lab. So these are the questions you're going to be addressing as you work through the lab. So the first 5, you have to manipulate the lab to answer. Well, one right here is just materials, but which material begins to boil first? What happens when you add those blocks to the containers? Observe and describe the movement of the energy. What happened when you decrease a container? Okay, so now that we've kind of looked at those, let's go ahead and work through the lab. So first thing I want you to do is put your beaker of water and your beaker of olive oil up on the burners. You will also need to add a thermometer to each container so we can record or monitor the temperature. Then you can click energy symbols and link heaters. This way we can observe changes in temperature simultaneously. Now that we've done that, notice when you click the energy symbol, you see these little letter E's. That represents the energy that is stored in each of these types of materials. So you can see iron has some energy, brick has some energy, so does water and olive oil. Now that you can see that, let's crank up the heat and add energy to these systems and observe what happens. So when you increase the heat, notice E, those little E's, this shows us that energy is moving into the system. So the system is the olive oil and the water, two separate systems. So let's make an observation about which one begins to boil first. So notice water has officially started boiling first. You can all see the steam coming off of that. So water boils first, but notice oil heats up more quickly. So now oil is finally boiling. So water boiled first, but oil did heat up more quickly in terms of how quickly the thermometer increased. As you observe this, you will see that energy is moving from the heating apparatus or the burner into the system. So energy transfers from one thing to another because they are in contact. And we can observe the same things in atoms. Now that we've done this, let's drop the brick and iron piece into each of the containers and see what happens. Doesn't matter which one. Brick, notice the drop in temperature. See what happens with the water. Again, we observe a drop in temperature. So what I want you to think about is once you have added other material to the system, the energy inside of it drops. And that is because the energy shifts from being just inside the oil or just inside the water into the brick and into the iron tab. You could see that again if we increased it. Notice now that they are heating up, but they are heating up. And also, not only is the liquid oil and the liquid water heating, but this will also eventually heat up the brick or transfer from the fluid, olive oil, into the brick and from the water into the iron tablet or into the iron block. Okay. The next step was to observe what happens when you cool it down. So whenever we cool it down, we're going to be removing energy from the system. So what I want you to observe right now is that as you are cooling it down, notice what the letter E's are doing. So E's represent thermal energy. The energy is leaving the system. So it's actually exiting the system and moving into the ice or the cooling apparatus. So energy is decreasing in the water system and in the oil system and moving back down into the cooled ice container. Okay, and you can just kind of keep observing that. And if you notice, it looks like there's only one little energy piece left in the oil container, right, compared to the brick. But we have basically cooled down or removed energy from both the water and the oil system. Okay. If we remove the other objects, we can pull even more energy out of the system. So now that we've done that, let's go back and take a look at our questions. So we've addressed questions 2, 3, 4, and 5. Now I want you to think through 6, 7, and 8. So think about what happens when you increase the temperature and you add salt. Also, how can you use this lab to represent what happens to energy when it is added to a chemical reaction? What would happen to the reaction? Would it happen more quickly? Would it happen more slowly? What would happen if you added energy to a chemical reaction? And lastly, kind of the big overall question here. When baking soda or sodium bicarbonate is combined with vinegar acetic acid in a glass beaker, the temperature of the beaker increases, meaning it heats up. Based on what you observed today in terms of thermal energy transfers, how can you explain heat? Where did it come from? So think about that, and we will kind of build on this thought as we move through the next lesson. So think about what happens when you combine two things in a container, a chemical reaction takes place, and the container itself heats up. So where is that energy coming from? So once you've finished your lab questions, make sure that you submit in the Create Assignment tab and that you've read the background portion and worked through the lab, kind of manipulating it on your own. Once you have finished that, you are done with the activity and assignment for Tuesday, January 12th. Have a great day.